Hi, this is our project proposal for artificial intelligence. Our team's project is AI agents mastering classic snake game with deep learning.
So the main problem that we are trying to resolve with this project is to optimize the classic computer game called Snake through the use of artificial intelligent agents that will essentially play the game in an attempt to achieve the highest score. So for this project, we have two agents that will be deployed to compare to see which one performs better in action. The two agents will be trained on CNN and MLP.
There will be two main course topics that we use in this project. First is learning agents. We will deploy a goal-based agent where its actions will be determined based on how close it is to its goal, which is to win the game. And then we will use two machine learning techniques, specifically CNN and MLP, which are both feed-forward artificial neural networks.
This is Xianglong Xu. I'm going to introduce the algorithm we came up with and how do we implement it. Because this project is about learning and improving the existing project, here I will first introduce the idea of rewards and penalty of the original project. The basic idea is that make the snake eat the food and get as long as possible. As we can see on the slides, the agent will get rewards when eating food and approaching the food. It will get penalty when it kills himself and away from the food. The longer snake is, more rewards and less penalty it will get. The formula about approaching and away from the food, making the snake think long-term when moving. As we can see, this is how our system works. In this project, we use two models to generate the snake move, but instead of focusing on structure of the model, we believe that underlying idea is more important. So, as we can see, we just want to focus on the reinforcement learning strategy instead of the model itself. We consider each state of the snake form a Markov chain, so we only consider the current state's influence on the next state. In the original project, the next state is considered by this attribute, including the food position, snake length, and head direction. After our discussion, we believe that snake body posture matters because under the same lens, different body posture could occupy different number of grids. So our strategy is just if the snake's body surround the empty grids, it get penalty. The picture just indicates this situation. The first thing we need to figure out is how do we store the body posture. Our solution is just using a matrix to represent snake body posture. Like one stand for the snake body, 0 stand for the environment, as we can see here. Our first try is just to regard each one in the matrix as a node. And doing the deep first search algorithm from the first point, during the searching process, if we search the point that has been searched before, so that we know the snake body has formed a circle. However, there is a shortage from this case, as we can see from the slides. A body posture like this can be considered as a model, can be considered as a circle from our algorithm. But this posture is what we want because we just want the agent learn how to fold himself the body. The second try is inspired by the traditional Chinese chess game Go. In the game of Go, a group of stones is considered captured when it's completely surrounded and has no liberties, resulting in the point for the opponents. So according to that, we just consider the empty grids instead of the snake body. Consider each 0 as a node again and search all the nodes connect to it. If one of the nodes reach the edge of the board, we can tell the grids are not surrounded by the snake. Then I'm going to introduce how we implement this algorithm. So firstly, the isSurrounded function check if a given 0 is completely surrounded by ones. It employs recursion and deep first search. The process is as follows. Search the connected nodes of the input node in 4 directions. If a 0 is found at the boundary, it indicates that 0 is not entirely surrounded, and the function returns false. If an unclosed 0 is found in the surroundings, the function returns false. If all surrounding zeros are enclosed by ones, the function returns true. And then the eCircle function counts the number of zeros entirely surrounded by ones in the entire game board. It iterates through the entire game board for each unvisited zero called the surrounded function to check if it's surrounded. If a surrounded function returns true, it means that zero is entirely surrounded, so add it to the circle set. Finally, return the length of the circle set, which represents the number of zeros surrounded by ones. As we can see the test matrix here, there are 3 zero contains by ones. If we run these scripts, we got 3 in the end.
Hi, this is Ashley,
And Maya.
and we're going to go over the results and conclusions of the 2 agents. So starting with the MLP versus CNN. So the goal of the MLP agent was to explore as much of the environment without bumping into a wall or getting itself killed. So therefore, its actions were not driven by the reward and penalty scores. However, on the other side, the goal of the CNN agent was to acquire as much food as possible and get the highest score. So its actions were very much driven by the reward and penalty. So because the motives were different between the 2 agents, when changes were made to the reward and penalty equation, we saw that the CNN agent performed a lot better while the MLP agent saw no improvement.
So talking about the results specifically for MLP versus CNN, if we look at both the old version and the new version, CNN performs better than MLP across all 5 metrics, which were average score, minimum score, maximum score, average reward, and average length. However, if you look specifically between the old version and the new version, MLP of the new version performs better with the minimum score 179, which you can see is bolded in the chart below. And similarly for CNN, the new version performs better across 4 metrics, which are average score, maximum score, average reward, and average length. So this provides some insight into how the old version and the new version compare, as well as the difference between the MLP and CNN results.
And now we're going to talk a little bit about how the original version compares with our newly implemented version.
What follows are comparison of the results between the old model and the new model that introduced new strategy. I will compare the difference between the old model and new model of MLP and CNN respectively. First is about the MLP model. The comparison of the overall performance of the new and old models is shown in the figure below. We conduct a total of 12 rounds of testing, and each consisting of 10 tests. The picture on the left shows the final range score of each round, and the right picture shows the final range snake length of each round. Through testing, we found that the old version performs better on range, with higher range scores and length. The introduced new mechanism makes performance worse. And next, we also compare about the range reward the snake can get in each step of MLP. We found that for range reward, the new version gets negative reward, which is less than the old version. That means the snake's movement becomes less effective, and the snake is more likely to kill itself. In summary, about the MLP model, we have such conclusion. The performance is worse in new version. We guess the reason is that MLP structure is too simple, so it can't catch important features and can't handle complex situations, which means that new implementation don't work in MLP model. And next is about the difference of CNN model in old and new version. We also compare the different performance in score, length, and reward per step. The curves trends of the 3 evaluation indicators are roughly consistent. You can see it here. By implementing a one-cycle strategy, it was found through statistics that the snake can get higher score and eat more fruits, and also get higher reward for each action on a branch. This demonstrates that in this case, by implementing the snake strategy of avoiding cycle points, it helps to improve the range performance, which means our new strategy works in this situation.
Let's look at the whole project. This project used the Pygame to develop the snake game, but let's just focus on the main components of this project. As we can see here, a class name named snake environment is defined inheriting from the gene library, indicating that this is intended to be used as a reinforcement learning environment compatible with OpenAI Gene. As we can see from here, the observation space is defined, which involves the snake environment and also the color of the snake. Make sure our model is able to distinguish the snake head and direction. In the function called step, which we can see from here, we define the strategy of the reinforcement learning. The compressed observation in our data is just here to indicate the data structure we mentioned to be used to detect the circles. At first, we define our penalty like this. The penalty is just about the circle number multiply the snake length, but it led to overfitting, since the agent get more penalty when it get longer and just keep circling and do nothing. Then we redefine our penalty like this. The multiply 0.1 just make sure our penalty limited to 1, which won't overwhelm the original strategy's value. And also let's take a look at the training file. The PyTorch and deep learning framework and also reinforcement learning library stable baseline 3 are used in this file, and also by creating the parallelized environment and employing the CNN based maskable PPO model, it achieved the training of the reinforcement learning agent capable for playing the snake game. And also in the end, we also get the periodic saving of the trained models and logs.
Okay, so now we're going to show a demo of our system. So again, as we mentioned, we are employing 2 agents, one CNN and one MLP. For both the CNN and MLP agents, to do that, we used a Python library called SB3contrib, the maskable PPO library, specifically to create and train our models. So going down here in the code, this is for the MLP agent. If you can see here, this is where we instantiate the model. We send in given hyperparameters, the learning rate, the batch size, the number of steps, etc. The same parameters are sent in for both the MLP and the CNN agent. So this is the CNN agent to show you guys here. And then once those models are trained, they are stored and saved into a folder. So over here, if you can look at the left-hand side of the screen, we have stored the saved CNN model and the saved MLP model. So once we have those things saved, we can now start playing the game. So I'm going to go over to the Snake Game custom wrapper. This code instantiates and lets us know what each agent is doing within the game. So to start, I'm going to quickly go over the inputs that the system uses, each agent uses to make its actions. So right here, if you can see on line 48, this is where we are setting up the game and we are defining the list of variables that the agent is given at each iteration of the game to make its decisions. So the input that we have is as follows: the snake size, so the current snake size, the position of the head, so the snake contributes the head of the snake, that's the beginning, the body, and then the tail, the end part of the snake. So we are given the heads position, and as well as the previous head position. So this would be the next block in the snake after the head position. We are also given the position of the food within the grid. So in the snake game, the snake's goal is to get the food. The food is placed at random spots in the grid. We are given that position, and then a Boolean variable that lets us know if the food has been obtained or not. So those are the major inputs of the system, and the outputs of the system I will show you guys in a minute once we demo the game. But I also want to quickly go over the reward and penalty system. This is the core of the game. If you can see the if and else statement is here, this is where we are deciding on the rewards and penalties that are required. So I'm going to go through each one quickly just to show you guys what they do. So this first if statement, this checks to see if the snake has filled up the entire board. If so, this means that you have won the game, and you get a reward penalty that is the maximum growth size. So typically the maximum growth size, I believe, is about 144, because the board size is a 12 by 12, so you can fill up the entire board. And then we just have a multiplier of 0.1 here for the reward, but this is the max reward that you can achieve. Next if statement checks to see if the snake has bumped into any wall or has bumped into itself. If the snake touches its own body, that means that the snake has unfortunately killed itself, so the game must be restarted and you have lost. So this, in fact, even though we are calling it reward, we have this negative symbol here. If you can see, let me just zoom in a little bit. There we go. Negative symbol here. That shows you that it's a penalty. So we're penalizing by this given equation here. And then again, this given equation here. And then again, we're multiplying that by 0.1 and returning that. All right, so the next if statement checks to see if the food obtained Boolean, that input variable that I mentioned before, is true. If so, the snake earns a reward of this given variable here. And then next is the else statement. So there are two parts of this else statement. So the first part is a penalty that is applied to the agent if its body is surrounding the space of the board. So what this means, this is kind of going back to our circle implementation. As you can see here, if the snake body posture is in a circle, that limits its chances of moving freely and moving towards the food. So therefore, the snake will receive a penalty using this equation. And then the next part of this else statement are tiny rewards and penalties that are added or taken away from the agent based on how far it is from the food. So if the agent is heading towards the food, this is a good sign, and the agent will receive a reward. And if the agent is not heading towards the food, it's heading away from the food, then the agent will receive a penalty. If you again can see that negative sign here, showing that the agent will receive a penalty if it's moving away from the food. I will go ahead and get started with the demonstration just to show you guys how the algorithm works, as well as the outputs of the system. So both agents operate a similar way. The only difference is the motive, which we talked about in a prior portion of our presentation. So I'm going to demonstrate the CNN algorithm today. Go ahead and run that. As you can see, the agent is moving around the board space, and it's trying to obtain the food, which is the red square here, which moves randomly about the board once the agent achieves it. And you can see as the agent keeps getting food, its body keeps growing longer and longer, and the score increases. Right, so the agent has unfortunately lost the game. So just to show you guys here, the outputs of the system, let me zoom in once more. So the outputs of each system, after each round, we receive the reward sum, the total score, the total steps that was taken from the agent, and then the total snake size. Okay, that concludes our demonstration for today. Thank you.